Welcome again to today's lesson. So my name is Mr. Meshak, and today we're going to be checking a new topic, that is 3 by 3 matrices. So 3 by 3 matrices. Now, so I'll just take us through what is here, so that you can be able to understand how to work matrices as we progress. So now the order of matrices. So an order of matrices just speaks on how a matrix is arranged. And we say a matrix is arranged row multiplied by column. So if we say a matrix is a 2 by 2, then that means it is the first one represents the row, the second number represents the column. And what are the rows? So the elements that have been written horizontally. If you take the elements horizontally, then those elements are in a row. So like this one, the first row, the second row, and the third row. Then the elements that are written vertically are called columns. So this A, B, G, B, H, and we have C, F, I. Then these ones are called columns. So rows, then we have this one being columns. Now, so for example, now in our case here, we have this one as a 3. So 1, 2, 3. So we say it's a 3 by how many columns? 1, 2, 3. So a 3 by 3 matrix. So we say this one is a 3 by 3 matrix. We have other type of matrices. One, we have the column. We have the column matrix. So the column matrix is a matrix with only one column. Only one column. So it can have as many rows as possible, but the column should be one. Then we have the row matrix. It's again a matrix with one row. So it can be this matrix A, B, C. So A, B, C, without considering all the other elements, can be considered as a row matrix. Then A, B, G, only this one. Then it can be considered as a column matrix. Then we have a square matrix. A square matrix is one that has the same number of rows and the same number of columns. So we can say a 2 by 2 is a square matrix, a 3 by 3, a 4 by 4. So you can check the rows and the column are the same. Row and column is the same, row and column is the same. Now, also we check a zero matrix just by its definition. It is just a matrix where all the elements are zeros. So there is no number. There is no, the number inside actually is 0 because it's a number. So the numbers inside, all of them are just zeros. So that one is called a zero matrix. Then lastly but not least, then we have the unit or the identity matrix. The I, it's abbreviated as I. So the I matrix is a matrix whose main diagonal elements are all one. Now the main diagonal is the diagonal from the left hand side on the upper row and the first column to the right hand side, the lower column, the lower row, and also the last column. So it is the first here and the last in this. So it is this diagonal. So this is always called the main diagonal. You can see all the other elements are zeros, but the main diagonal has 1 as the number. So 1, 1, then 0, 0, then 1, 1, 1, then 0, 0. This is a 3 by 3, this one is a 2 by 2. There is something you need to note. When you multiply any matrix, so in our case here we take a matrix P, and you multiply with I, the identity matrix, you just get the matrix P. So this, you can take it by, as we talk about a unit, is just represented by 1. So that means, since this one is an identity matrix, if you multiply the same way you multiply a number by 1, if you multiply a number by 1, then you get the same number. So this is just the same thing. You multiply P times I, you get P, or I times P, you get it to be P. Then lastly, we have the singular matrix. A singular matrix is a matrix whose determinant is 0. So we shall check what determinants are as we progress. But now it is a matrix whose determinant is 0. So these are what you need to know for now. when we come to operation of matrices. So the order is very important for you to know. The square matrix, you need to know the identity matrix. This one plays a major role when it comes to operation of matrices. And you also have the singular matrix. And it can be used, you can be given a matrix and you're supposed to solve for something, but you're told it is a singular matrix. So the aspect that you know what a singular matrix is, then you'll be able to evaluate any matrix that you have been given. So having said that, I want us now to go and I want us now to check on operation of matrices through some few examples that we shall have. So let's check the operation of matrices.